Another type of optimization problem is the maximum revenue problem. Best Buy sells an average of 200 TVs a week for $350. A research company suggests that for each rebate of $10, the number of TVs sold will increase by 20. How large a rebate should the store offer to maximize revenue? Let's minimize this a little bit, give us some room to work. Like our other max-min problems or optimization problems, maximum and minimums occur when the derivative is equal to 0. The first derivative is equal to 0. The tricky part of this type of problem is building the equation. To do this, let's make some changes and look for a pattern. Revenue will equal the price times the price times the number of TVs sold. So we'll do TVs sold. So the original would look like 350 times 200. When I give a rebate, I'm going to essentially decrease the price by 10. So my revenue will then be 350 minus 10. The TVs sold will increase by 20, so that will be 200 plus 20. If I make another change, I can get 350 minus 20. My TVs sold will increase by 40. Well, let's look at those two numbers once, this 20 and this 40. That really comes from making a change of 10 two times. The 40 was making a change of 20 two times. If we follow this pattern through and make X number of changes, we can get a revenue of 350 minus 10 for every change that we make, and TVs of 200 plus 20 for every change that we make. This becomes the formula that we're going to be working with. Okay, so let's start finding the first derivative. Let's just slide this up. To find the first derivative, I could expand this out and get a polynomial, or I could use the product rule. That means I'm going to take the derivative of the first part, negative 10, times the second, 20x, plus the derivative of the second part, 20, times the first. Now I do have to expand it out at this point with a little distribution. This is going to give me negative 2,000 minus 200x plus 7,000 minus another 200x. So my final derivative becomes 5,000 minus 400x. Alright, this is a little messy. Let me clean up some stuff here. We don't need this anymore. Let's take this and move that up. I'm also going to get rid of this part here. Okay. Our derivative equal to 0 will give us our maximum or minimum values. A little algebra will tell me that x will equal 12.5. Now, remember that x was the number of changes that we made to the rebate, not what the rebate actually was. So what this means is our rebate will probably be a maximum when we make 12.5 changes of $10, or we give a rebate of $125. We do have to check to make sure that the 12.5 is indeed the maximum value. Let's do that using our first derivative rule. Let's get a new page. All right, so I'm going to bring back our first derivative test. There's 12.5. I'm going to check something that is less than 0. Less than 12.5. I'm going to use 0. When I plug that into my derivative, remember that was 5,000 minus 400x. If I plug in a 0, this whole thing becomes positive and my function is increasing. Now I'm going to punch in something greater than 12.5. Let's use 100. Well, this part here becomes a very big negative number. My whole function becomes negative and the original is decreasing. So 12.5 is indeed a maximum value. So to answer our original question, the rebate offered should equal $125. Some other questions that may be asked will be, what price are we actually selling the TVs for? So if the original price was $350, but we're giving a rebate of $125, the new price becomes $225. They could also ask you how many TVs are being sold. The TVs sold were 200 plus 20 for every change that we made, and we made 12.5 changes. So that would equal 450 TVs being sold. The last thing that could be asked would be, what is the maximum revenue? Remembering that revenue was price times the number sold, we're going to take $225, multiply it by 450 TVs, and our maximum revenue is $101,250.